All right, so today we're going to look at evaluating limits analytically. So Monday and Tuesday you spent time figuring out how to evaluate limits from a graph. We're going to quick review that in this first question here. So we are given the graph of f of x, and we're told that it's this quadratic x squared plus 2x minus 4, and we want to evaluate the limit as x approaches 1. Okay, so zooming up a little bit on our graph, we can see the x value of 1 here. We want to see what is our function doing as we approach 1 from the left-hand side and the right-hand side along our curve. So when we trace our function left to right as x is approaching 1, we get that y value of -1. As we approach right to left along our curve, we are also getting that value of -1. So we can see that as we approach x from either side, we are getting closer and closer to -1. So you might want to write out that the limit as x approaches 1 from the left of f of x is equal to -1, and the limit as x approaches 1 from the right of f of x is -1 as well. Since that left-hand and right-hand limit match, we get to say that the limit as x approaches 1 of the function is -1. Okay, so that's just a quick review on how to look at these things graphically. The rest of these notes is all about how to analytically solve for these limits, evaluate these limits. So this is doing a lot of algebra. You might want to pause the video right now and go ahead and, if you haven't yet, read through these strategies, and then meet me at example 1 when you're ready. So sometimes, depending on our function, we are able to just directly substitute our c value into our function to evaluate our limit. So here, we're asked to evaluate the limit. Oops, it's a little messy. We're asked to evaluate the limit as x approaches 1 of x squared plus 2x minus 4. And if I go ahead and just plug in that value of c for x, I'm looking at that being 1 squared plus 2 times 1 minus 4. When I simplify that, I get 1 plus 2 minus 4, which equals -1. And you can see that that matches what we found above in the graph. Okay, we were given the same function. We were asked to evaluate the limit graphically here, and then we just did so analytically using direct substitution down here. Okay. Example 2, we are asked to evaluate the limit as x approaches 2 of 3x squared minus x plus 1. And I'm told to do this using direct substitution. So what that means is I'm going to replace every single x with that c value and find that the limit as x approaches 2 of 3x squared minus 3 plus 1 is whatever 3 times 2 squared minus 2 plus 1 is. Okay, so that will give me, let's see, 3 times 4 minus 2 plus 1. That gives me 12 minus 2 plus 1, which will get me 10 plus 1, which is 11. So what we get to say is that the limit as x approaches 2 of 3x squared minus x plus 1 is equal to 11. And that's our final answer. You'll notice on the key or the guided notes that are posted in Google Classroom, accompanied with this problem is a picture of the graph. Okay, so you can check out what does this curve look like graphically, and as x approaches 2, you will see that the function is approaching that y value of 11. All right, again, we are going to evaluate this limit. We're going to try direct substitution because that's really our only tool at this point. So the limit as x approaches 5 of the square root of 4x minus 9 is going to be equal to the square root of 4 times 5 minus 9, which is equal to the square root of 20 minus 9, which is just the square root of 11. This tells us that the limit as x approaches 5, the square root of 4x minus 9 is equal to the square root of 11. And again, you guys are welcome to check out how that matches with the graph that is provided for you on the guided notes. Example 4, we're looking at the limit as x approaches pi over 8 cosine of 4x plus 7. So I'm going to go ahead and substitute in that c value of pi over 8 into my function. So we'll find that the limit as x approaches pi over 8 of cosine of 4x plus 7 can be found by computing cosine of 4 times pi over 8 plus 7. Hopefully you notice a quick cancellation here and see that this is really just asking you for cosine of pi over 2 plus 7. And then using our knowledge of the unit circle, we know that cosine of pi over 2 is just 0, and 0 plus 7 is 7. So we're able to make the claim that the limit as x approaches pi over 8 of cosine of 4x plus 7 is equal to 7. And again, I encourage you guys to check out the connection between this statement and this analytical work and the graph that's shown on your guided notes posted in Classroom. All right, last one for this direct substitution as far as the examples go. We're looking at the limit as x approaches negative 2 of x squared minus 4x minus 10 divided by x. Substituting in those values, we'll find in the numerator that it's negative 2 squared minus 4 times negative 2 minus 10 all over negative 2. Here we just really have to be careful with all of the negatives, right? We know a negative squared is going to be positive. We have negative 4 times negative 2, which would give us a positive 8, and then minus 10 at the end, all divided by negative 2. We can simplify that numerator to be 12 minus 10 over negative 2, and furthermore, we can simplify that to be 2 over negative 2, which will be negative 1. That tells us that the limit as x approaches negative 2 of this rational function, x squared minus 4x minus 10 over x, is equal to negative 1. And as with all the other ones, all these other examples, you do have that graph provided on your guided notes, and you can go ahead and check that out.